Hello, this is Mr. Win, and this video is over solving systems using Gaussian elimination. So Gaussian elimination is another method used to solve systems. It's like a visual way of doing elimination in a special table called an augmented matrix. That matrix is made using coefficients of standard form equations. Just like when you do elimination, there are three things we're allowed to do with augmented matrices called elementary row operations. We can multiply an equation by a number, we can abstract equations to eliminate terms, and we can switch the order of equations. And although we can solve a system full of Gaussian elimination, we're going to focus on the setup only and stop at REF, which is row echelon form. This is where you have one-step division to solve for a variable, which then you plug in, do backward substitution to find the other variables. One way of knowing if you're there or not is to draw a downward diagonal line and see if every number below that is 0. So here's an example of that picture. Notice these three numbers are 0. This is the diagonal. This is called an upper triangular matrix. And that's it. So first we're going to turn this system equation into an augmented matrix. So I'm going to make the chart. There's an x column, a y column, equal sign, which is a dotted line, sometimes it's invisible, and an answer column. For the first equation, next to x is positive 2. Next to y is negative 3, and the answer is 16. Second equation, next to x is positive 4. Next to y is positive 2, and the answer is 20. That's it there. Second problem, we're going to do the reverse. Turn this augmented matrix back to a system of equations. So, next to x is negative 5, next to y is positive 8, so plus 8y, equal sign, the answer is 36. Second equation, 0x, so I don't write that, but positive 5y equals 10. Notice this is REF because there's zeros underneath. This is a one-step division problem. I can divide by 5, get y equals 2, and plug into the equation above to get x. By the way, there's still no solution, infinite solutions. If you have a true statement, no variables, 0 equals 0, that's infinite solutions. If you have a false statement with no variables like 0 equals 1, that means no solution. Let's try an actual problem. Use Gaussian elimination on the following system. So first I'm making a matrix. For x is 2, for y is negative 3, answer 16. Second equation, for x is 4, y is negative 2, answer 24. I'm going to say R1 or row 1 turns into negative 2 times R1. So I'm going to multiply the first row by negative 2. So 2 times negative 2 is negative 4. Negative 3 times negative 2 is positive 6. Negative 16, negative 2 times 16 is negative 32. Second row stays the same. And then I basically do adding downwards elimination. So next I'm saying R2, the second row, will turn into R2 plus R1. So the first row is the same, but row 2, 4 plus negative 4 is 0. Negative 2 plus 6 is 4. 24 plus negative 32 is negative 8. This is REF. I'm going to turn these into their equations. So the first equation is negative 4 for x, positive 6 for y, answer is negative 32. No x, positive 4y equals negative 8. This is one-step division, so I get y equals negative 2. I'll plug this negative 2 into the first equation. So I made this y green, I plugged in negative 2, I multiplied, I moved the 12 over by adding, then I divided by negative 4, 5, and the answer to a system is always a point and a coordinate. So the answer is 5, negative 2. By the way, the same problem, you could have done a shortcut. Instead of doing 3 steps, you could actually do 2 steps. You could actually say row 2 turns to R2 minus 2 times R1. Instead of rewriting R1, I can just say, oh, just subtract double that. It's more mental math, but you save a little bit of writing. But I think everything else will be the same as that. Alright, if you have any questions, ask your teacher. Thanks for watching. Bye.